Alright, now let's add some movement to our player object. Start by selecting the player object in the scene. Click Add Component and first add a Circle Collider to it. Next, add a Rigid Body 2D. Now, tweak some settings in the rigid body. Set the collision detection to continuous. Set the sleep mode to never sleep. This ensures our physics are accurate and the player object won't randomly sleep or skip collision. Now, let's write the movement logic. In the asset, create a new folder and name it called script. Inside, right-click, create a C# script named player. Double-click to open this script in Visual Studio. Inside the script, remove the default start and update methods. We don't need them for now. Now here, let's add some variables. A serialized field private float called start speed. A private float called speed. Private integer called speed magnitude. And the private integer called direction index. Let me explain this. A start speed is the base speed of a player, which we can set from the inspector. Speed is the actual runtime speed of the player. And the speed magnitude, we use this as a toggle to control the movement, like 1 is equal to move and 0 is equal to stop. And at the last, a direction index keeps a track of which direction the player is currently moving. Next, we will add a wake method, which runs once when the script is loaded. So, write private void awake, and here set the speed is equal to start speed. Set the speed magnitude to 1 and the direction index to 0. Since we are dealing with physics and rigid body, we are using fixed update method. Inside the fixed update method, write vector3 position and set this equal to transform.position. Now, set the transform.position is equal to position. In the middle of this line, set the position plus equal to speed multiplied with speed magnitude and time.fixed delta time. We need one more variable, a serialized field private vector3 array called directions. And here multiplied with time.fixed delta time, direction index dot normalized. This array holds all 4 possible diagonal directions the player can move in. Let me break this down. First, we grab the current position. Then we calculate the new position by adding the direction we are currently moving in, multiplied by our speed and magnitude, and scale by time.fixed delta time to keep movement smooth across different frame rates. Dot normalize ensure that each direction has a length of 1, so the movement remains consistent no matter what. And at the last, we update the object's position with the new value. Now, save the script and head back to the Unity. Select the player, drag the player script onto it, and here set the start speed to 2. Don't forget to set the rigid body's gravity scale to 0. To make sure everything looks right, select the big background square and set its ordinary layer to -10. Select the center square and set its ordinary layer to -8. This keeps the player's sprite visible above everything else. Now, select the player again and look at the direction array. Set its size to 4. Now, enter these 4 vectors, 1, 1, -1 and 1, -1, +1 and -1. These are the diagonal direction that forms a square path. Let's now rotate everything to match the path visually. Select the background square and rotate it 45 degrees on the z-axis. Do the same for the player. set its Z rotation to 45 degrees. Now hit play and you will see the player object moving diagonally in a loop. Everything is working as expected. We have got basic movement fully set up. In the next video, we will learn how to change the direction, so stick around.